Hi everyone, I'm Andrea Angella and welcome to the Practical C# video series. Let's talk about equality in C#. I have a solution in Visual Studio and I have a struct called score with a string name and an integer value and a constructor that takes a name and a value and a toString method. Okay, so here I have a lot of tests that basically are checking that the equals method between two scores. And as you can see, I'm checking that two scores with the same properties are actually the same, that a score is equal to itself, a score is not equal to null. Then you can see that we have that a score with different names are different, a score with different values are different, and so on. I have a similar method that check when you actually use object. So this is going to use the not type specific version of the equality. And right at the end, I also have a test to check that a score is actually different than any other type, like, for example, integer in this case. And you can see that on the left that all the tests are actually passing. And this is actually quite interesting. If you use structs, you get equality for free by default because the framework implements it for you. So this is a very good advantage of using structs. So if you want to create an immutable value type that support equality out of the box, I definitely recommend you to use structs. There are some advantages, like the fact that structs are value types and they're using the stack for memory, so they are memory efficient. So there is no use of the garbage, so you create less garbage if you use structs, and also less indirection in the way the actually underlying implementation is accessing the memory. Of course, the downside is that because the stack is used, if you pass around structs, there is a lot of copy of memory involved. So you should consider using structs only if the total amount of memory that each instance of a struct takes is not too big. And usually the recommendation is 16 bytes, but it depends by your application. But how this is implemented, we can have a quick look. Each value type actually implement implicitly the value type class. And let's have a quick look at the underlying code. Actually, instead of doing directly here, we can take down into the equality methods. As you can see here, the framework actually does a user reflection to get all the fields for you and automatically does the equality. So it's obviously not the most efficient implementation. It's generics. It works, so most of the time you probably don't need to care about, but if you want to improve performance, you can implement the equality yourself for structs, but it's not strictly needed. Right, so what happens if you change the struct to a class? Here you have a continuous testing session. The tests are going to run now, and you will see that some of the tests will pass just because we are lucky, because automatically reference types like classes are automatically using a reference equality. And if the two objects are different, of course, the references will be different. So this test will pass. But obviously, the tests that are actually checking that the two objects have the same values inside are gonna fail. So we need to implement the equality explicitly because the framework doesn't provide it for us. And in order to do that, I'm going to use ReSharper, and I use I press Alt Insert, and it generates equality members. You select the members you want to generate the equality, and then make sure you check that you implement IEquotable T, is a good practice to do, and then press Finish. What ReSharper does is automatically implement IEquotable Score, implement the equality for score, that does some basic checks, like checking for null, checking that the two references are equal. This is kind of a performance optimization. If two objects are actually the same, pointing to the same object in memory, there's no point to actually check the values themselves. And then here you can do some logic that actually check the values of the objects. And also, we need to implement the equals object method that is defined in the object superclass, with some extra checks at the beginning, making sure that two different types are always returning null, false, and then it delegates to the type-specific equality. And it's always a good practice to generate a get dash code, but I'm not gonna go into the details in this particular video. So if I, so this should now pass as well. And let's have a look. There we go. So now all the tests pass. You need to write some extra code in order to implement the equality for a reference type. So it's always implement I equatable t and equals for the object. And ReSharper can help you in this case. Keep in mind that when you implement equals method, you need to make sure that all the properties that our object is always equal to itself. Let's see, if A is equal B, B equals A, and A equals B, and B equals C, then also A must be equal C. That should be preserved. And this is it about equality. It's a bit messy in C#. It's not the most nice language for implementing equality. But if you follow this pattern and you use tools like ReSharper, it shouldn't be too difficult to implement equality correctly. Hope you enjoyed the video. If you like the channel, if you like the video, please like it, share it with your friends, and if you are interested about C#.NET, please subscribe to the channel. Thank you.